So you have to also find your endpoints. So this has to be bound. So this is the easiest way to parametrize a curve. It does take a little work. You can avoid all of this if it's conservative. That's what's nice. But if I look over here, there's an isolated variable y. So this y here is isolated. That means it's not inside some kind of other function. So I'm going to set y equals to t. Then once I set y equals to t, because they told me there's a parabola, that's my curve, and x is y squared, then x is t squared. So that gives me the x. Then I have to get the upper and lower limits of the t. So t equals 0. Usually that's how it works. What that gives me is that p is 0 and q is 0. And if I go back to the original equation, I get 0, 0.
How is the problem that we're actually doing? It's x equals y plus 1. So if you add a 1 to it, or
we'll go back to yours and see in a second. Okay. So, but over here, how did I get the endpoint 1? Well, they told me that I need to go to 1, 1. So if I plug in 1, 1 in here, I get x equals 1, y equals 1, and x equals 1, y. If I plug in, they said to do that, I think.
Yeah. So how does
0, 0 to 1, 1. That's how you solve it. The easiest way possible is just to look at that first component. If the endpoint has to be 1, you put 1 in for the answer. T squared equals 1 will give you that t equals 1 as the final. So that's how you get this range.
Can you show us an example of that range where you don't have 0, 0, and 1, 1? So for this one, we have like 1, 0, and 2, 1.
Let me give you that as like an extra little sheet to hand out to you because it'll get really messy. So I have to think about how to either make that, construct that example so that the algebra is doable.
That's fun.
No, the problem actually works out nice.
Yeah.
So I'm going to show you the how to do the parameterization of that problem in a second.
Thank you.
But you're right, the parameterization is the hard part, and that's why you like the conservative ones because it makes it easy. So let me go back to my solutions and see if I can. Oh, and I put all the answers to the concept questions on here so that you can look at them. But do try them. How far are you guys? All right, I'm going to do that one more time on the board. This is the time we have to get things done. We are just so short on time to work. Can I show you this and you guys not look at the whole thing? Because otherwise you won't get that cadet developmental opportunity. So here, what I did is I set y equals t. I think I gave you the hints, right? Set y equals t. And number 4? Yeah. Why did I do that? I shouldn't have given you any hints. Then x is t squared plus 1. Y goes from 0 to 1, so t goes from 0 to 1. Otherwise, since I set y equals t, then t goes from 0 to 1. And I just do a little check. Does at x equals 1? It does. At t equals 0, x equals 1. And at t equals 1, x equals 2. So it fits. If you go back to the very top.
So you split it into x, y, and then do each of them separately, or like?
Yeah. So in the way they wrote this, the p is x squared and the y, the q is y e to the x. And they gave me this formulation, like it's on this curve, x equals y squared plus 1, that's given to you. Then, and it goes from x equals 1, y equals 0 to x equals 2, y equals 1. So all of this information is important. So if I go look up at that equation, the p and the q, the easiest isolated variable is y equals t. So then x has to be t squared plus 1, right? And y, they said, if I look at the y coordinates above, like up here, the y coordinates are going from 0 to 1. So y goes from 0 to 1, so t goes from 0 to 1. But I just checked. Joseph, ask, where did you lose me? Okay, up here. Step 1, if I was breaking this down as step 1 to parameterize, steps for parameterization. Step 1 is to look at these two coordinates. The coordinates are, I can't see on my screen, it's too small. X squared is the first coordinate, and the second coordinate is y e to the x. See that? You good with me there? This is number 4. Okay, so I just isolate those two coordinates, pull them off. Then I look and see if any letter is sitting by itself. Y is sitting by itself. Everything else is tied up in functions. So I set my t equal to y. Right? That means my x is t squared plus 1. Now, I don't know where the start of t and the end of t is, but they told me that the y coordinate is 0 and then the end y coordinate is 1. So since y goes from 0 to 1, then t goes from 0 to 1. So then I just checked that the x coordinate goes from the right places. So at t equals 0, if I plug it in to this, I get x equals 1, which is where it starts. And at t equals 1, I get x equals 2. So I'm using these points right here. Logan, you understand it?
Yeah, I had my sign and my plus 1, but I had minus 1.
Get Joseph on board. Like, show him what's going on with how to find the t's. Anybody else?
Can we go through differentiating the R to
Do you understand?
Where that came from?
like how do you?
Do you want it for this problem? Let me go to the other problem because otherwise you have something. I have to make another problem. How did this? You just take the derivative. T squared is 2t. 1. So that's the easiest.
Y is so little.
Plugging it in here, so you get the water, and taking the t and plugging it in here. So you plug in x. What you have in terms
Oh, I
of
see.
it's on the side because as you're learning this can go into your formula sheet that you're making.
What was the point of getting the R and T in terms of T?
Because what you're going to do is when you integrate, you're plugging it into, see this formula here? You're plugging it into these type of formulas. So you need to take the hard plate apart and so you calculate all these things and you're integrating. That's why you need it.